Supermassive black holes are cosmic powerhouses found at the centers of nearly all large galaxies, including our own Milky Way. With masses ranging from millions to billions of suns, their immense gravity governs the motion of stars, shapes gas flows, and influences the life cycle of galaxies. Though invisible, supermassive black holes often reveal themselves through bright accretion disks and powerful jets, forming quasars and active galactic nuclei. Their origins remain one of astronomy's biggest mysteries, possibly seeded by early black holes or collapsing gas clouds. Over cosmic time, they grow by devouring matter and merging with other black holes. Through feedback mechanisms, they regulate star formation by heating or ejecting interstellar gas. Their mass is strongly linked to the motion of stars in the galactic bulge, suggesting a deep coevolution between black holes and galaxies. These giants also generate gravitational waves, helping us probe the fabric of space-time itself. True or false? Supermassive black holes emit no light and therefore cannot be observed in any way. False. While the black hole itself is invisible, the accretion disk and relativistic jets surrounding it emit intense radiation across the electromagnetic spectrum, making them observable with radio, X-ray, and infrared telescopes. Which object is commonly found at the center of a large galaxy? A supermassive black hole. Fill in the blank. The supermassive black hole at the center of the Milky Way is called blank. Sagittarius A. Fill in the blank. A black hole's boundary, beyond which nothing escapes, is known as the blank. Event horizon. What causes a quasar to form around a black hole? Accretion of matter at high rates into the black hole. Fill in the blank. A supermassive black hole's rotation can distort spacetime in a process called blank. Frame dragging. True or false? Supermassive black holes have no influence on the evolution of their host galaxies. False. SMBHs play a major role in galactic evolution by regulating star formation, generating feedback through energy outflows, and influencing the dynamics of the galactic bulge. Fill in the blank. The bright, swirling disk of gas around a supermassive black hole is called the blank. Accretion disk. What phenomenon is associated with two supermassive black holes merging? Gravitational waves. Fill in the blank. Supermassive black hole feedback can prevent star formation by expelling blank from a galaxy. Molecular gas. True or false? The formation of supermassive black holes is still not fully understood by astrophysicists. True. Fill in the blank. When a supermassive black hole accretes material rapidly, it can become a blank. Quasar. Which part of a galaxy is most affected by the mass of its central supermassive black hole? Galactic bulge. Fill in the blank. The correlation between SMBH mass and stellar velocity in galaxies is known as the blank relation. And sigma. Fill in the blank. Supermassive black holes may grow by merging with blank during galaxy collisions. Other supermassive black holes. How do supermassive black holes regulate the growth and structure of their host galaxies over cosmic time? Supermassive black holes influence their host galaxies through a process known as AGN feedback. As they accrete gas, they release vast amounts of energy in the form of radiation, winds, and relativistic jets. These outflows can heat surrounding gas, preventing it from cooling and collapsing into stars, or expel it entirely from the galaxy's central regions. This regulates star formation, particularly in massive galaxies, and helps explain the observed correlation between black hole mass and bulge velocity dispersion. Over billions of years, this feedback mechanism shapes galactic morphology, suppresses runaway growth, and contributes to the coevolution of galaxies in their central black holes. True or false? The spin rate of a supermassive black hole can approach the speed of light, significantly affecting the surrounding spacetime. True. Which which phenomenon results from the relativistic effects near a rapidly rotating supermassive black hole. Frame dragging. Fill in the blank. The blank is the distorted region around a rotating black hole where spacetime itself is dragged. Ergosphere. If a star is 5,000 light-years from a quasar's core and its radiation front expands at 300,000 kilometers per second, how long will it take for the radiation to reach the star? To calculate how long the radiation takes to reach a star 5,000 light-years away, we first convert the distance into kilometers. 1 light-year is about 9.461 times 10 to the 12 kilometers. So 5,000 light-years equals 4.730 5 times 10 to the 16 kilometers. We then divide that by the speed of light, which is 3.0 times 10 to the 5 kilometers per second. This gives us roughly 1.577 times 10 to the 11 seconds. To convert seconds to years, we divide by 3.154 times 10 to the 7, the number of seconds in a year. The result is 5.0 times 10 to the 3 years. So the radiation would reach the star in approximately 5,000 years. Which of the following observatories can detect gravitational waves from merging supermassive black holes? LISA, Laser Interferometer Space Antenna. If matter near supermassive black holes accelerates outward in a jet at 90% the speed of light in a vacuum for 10,000 years, how far will it travel? To find how far matter travels at 90% the speed of light over 10,000 years, we use the formula: distance equals speed multiplied by time. 90% of light speed is 0.9 times 3.0 times 10 to the 5, which equals 2.7 times 10 to the 5 kilometers per second. We convert 10,000 years into seconds by multiplying by 3.154 times 10 to the 7, giving us 3.154 times 10 to the 11 seconds. Multiplying speed and time, we get 2.7 times 10 to the 5 times 3.154 times 10 to the 11, which equals approximately 8.52 times 10 to the 16 kilometers. True or false? Supermassive black holes form exclusively from stellar mass black holes that grow over time. False. While growth contributes, many supermassive black holes may have formed from direct collapse of massive gas clouds or primordial seeds, not just stellar remnants. Fill in the blank. LISA will observe supermassive black hole mergers using blink rather than electromagnetic radiation. Gravitational waves. Why do supermassive black holes sometimes stop star formation in their galaxies? They eject or heat gas via feedback mechanisms. Fill in the blank. Jets launched from the poles of some active supermassive massive black holes can extend for blank of light years. Millions of light years. True or false? The mass of a supermassive black hole is unrelated to its host galaxy structure. False. There is a well-established correlation, like the M-sigma relation, linking supermassive black hole mass to stellar velocity dispersion in galactic bulges. Fill in the blank. The process by which a black hole's mass affects galaxy star velocity is described by the blank relation. M-sigma. Which metric solution describes a non-rotating supermassive black hole in general relativity? Schwarzschild metric. A black hole grows from 1 million to 4 million solar masses over 100 million years. What is its average growth rate? To find the black hole's growth rate, we subtract the starting mass from the final mass. 4 million minus 1 million gives us 3 million solar masses, or 3 times 10 to the 6. We then divide that by the time, which is 100 million years, or 1 times 10 to the 8. 3 times 10 to the 6 divided by 1 times 10 to the 8 equals 3 times 10 to the minus 2. So the average growth rate is 0.03 solar masses per year. How did you do? Tell us in the comments below. And thanks for watching BrainyKidz. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy friends.